Why understanding distortions matters. Map distortions influence real-world decisions with significant consequences across multiple sectors. Let's examine these impacts through key categories: travel and logistics. Standard maps misrepresent flight paths and shipping routes. The straight lines on Mercator maps don't reflect actual curved Great Circle distances, the shortest paths between points on a globe. A Los Angeles to London route appears shorter than reality, affecting scheduling and fuel calculations. Shipping companies lose millions annually when routes between Shanghai and San Francisco don't account for the northern curve near Alaska. Policy and global priorities. The exaggerated size of northern nations on Mercator projections creates visual bias in international relations. When Africa appears smaller than Greenland, its environmental and economic importance gets visually diminished. During the 1982 UN Convention on the Law of the Sea, delegates had to establish special mapping standards to resolve maritime boundary disputes caused by different projections. Emergency response. During Hurricane Katrina, some relief teams wasted critical hours because Mercator maps made affected towns appear equally distant from aid centers when they weren't. First responders relying on these maps reached survivors hours later than necessary, a delay that proved fatal for some. Floodplain maps using improper projections have similarly misidentified evacuation zones during recent floods. Agriculture and infrastructure. Projection errors cause up to 15% discrepancy in reported farmland sizes nationwide, equivalent to misjudging a 100-acre farm as 85 acres. These inaccuracies affect irrigation planning and equipment needs. Pipeline routes plotted on flat maps often require extra materials when built, as a proposed 100-mile route might actually measure 110 miles, accounting for terrain. Military and high-stakes decisions. In the 1991 Gulf War, artillery units reported targeting difficulties because their maps didn't adjust for projection variations across the battlefield. One unit fired shells nearly 500 meters off target, the length of 5 football fields, before switching to GPS-corrected coordinates. Modern military systems now automatically convert between coordinate systems to prevent such errors. Education and perception. Students learning from Mercator maps absorb distorted views. Brazil appears smaller than Alaska despite being nearly 5 times larger. These early impressions persist into adulthood, affecting business decisions and cultural attitudes. When New York City students were shown accurate comparisons, 68% couldn't correctly identify which of 2 trading partners actually had the larger economy. Climate science. The common 8 to 12% distortion in Arctic areas affects ice loss calculations, potentially underestimating sea level rise by inches over decades. During the 2015 Paris Agreement negotiations, some delegates initially questioned climate models until shown corrected projections of melting patterns. Urban planning. The New York MTA found subway routes required 5% length adjustments when accounting for projection effects, adding millions in costs. A proposed mile-long road might actually measure 1.2 miles when accounting for elevation changes, creating budget overruns across large projects. Public health. Early COVID-19 tracking using standard maps obscured transmission patterns between cities. When the CDC switched to customized projections, they discovered infected travelers were moving along highway corridors that flat maps had visually separated. These examples reveal how map distortions compound into real-world consequences. The container shipping industry's annual $47 million loss from routing errors could fund 1,000 new school buses. The 15% farmland measurement discrepancy equals misallocating enough water for 200,000 households annually. One striking case occurred during the 2004 Indian Ocean tsunami, when relief maps made some coastal villages appear equidistant from supply centers. Rescuers following these maps took 3 extra hours to reach one community, time that might have saved dozens given the 90-minute window for effective flood response. Later analysis showed proper projections would have revealed a direct overland route obscured by the map's distortion. Understanding these limitations helps us use maps more effectively. Tools like the truesize.com allow quick comparisons. Dragging Canada over Africa reveals the continent could contain 3 entire Canadas with room to spare. Flight path visualizers show how straight routes become curves in reality. While technology improves accuracy, the fundamental challenge remains. No flat map perfectly represents our spherical world. The key is recognizing these distortions to make better informed decisions, whether planning a farm, sending aid, or understanding global relationships. The maps we choose inevitably shape the reality they represent. Every map you've ever seen is wrong in some way. Flat projections must distort the spherical Earth, stretching, shrinking, or warping reality to show certain features clearly. The Mercator map makes navigation simple, but blows up polar regions. Equal-area maps show true sizes, but twist familiar shapes. Peel back your map like an onion skin. What lies beneath the familiar shapes? That straight-line flight actually curves across the globe. Alaska only dwarfs Mexico on paper. Cartographers choose which truths to keep and which to bend. Next time you unfold a map, ask, what story is this projection telling?